Okay, can we start? Or? Yeah. Okay, good morning everybody. Let's continue our sophisticated and complicated discussion about what healthcare is and what can be done. We are today in the fifth day, and we started yesterday about key activities. And key activities is where operations management, system science, and this kind of technical things can really help out in making healthcare better. So we discussed the flow and resource efficiency, which is a basic framework. Then we talked about processes, coordination, devices, and we had this hierarchy of units of analysis. You're familiar with the word unit of analysis? In all kind of system thinking, you have to be very clear about what is the level where you are talking. We're talking about the whole world, we're talking about the region, about the city or block of the city, about community or a group or individual. So these are sort of units of analysis. A typical error in the thinking and speaking of politicians and lay people is that they mix units of analysis quite freely. So if you have as an individual or personal example, then you think that everybody has it, or think that things that are true on an individual level can be straightforwardly extrapolated to a whole society. So that's the basic point here. I'd also like to add that the two topmost things, where we have the step and the workflow, they are driven by domain knowledge. So if you want to make these steps better, you typically need the domain technologies to improve. So in healthcare it means clinical medicine, nursing science, pharmaceuticals, stuff like that. If you want to improve the team, then it's teamwork, human relations, social psychology, that sort of issue. Then, as we discussed yesterday, when you move to the unit of analysis of a process, then that's the step where management and industrial engineering, operations management, system thinking enters the picture. Because then it's not any longer the question of doing the steps better, of higher quality or faster or with better results. It's a matter of how to combine the steps into processes and flows and organization. So that's a point with this picture. This we already discussed, bottlenecks. Okay, then okay, again we have to talk about the birds. Because when you look at processes, it's the process as double entry bookkeeping is a conceptual construct. What you see depends on what you expect to see. And there are a number of sort of conceptual frameworks that help you sort of identify the important things and see something sharply and leave some other things behind. So this is one example of how you can look at the processes. This illustrates the situation that is written up in one of these papers that Srikant sent yesterday, right? The McKinsey paper on the hospital flows. So that explains the situation where you have problems in getting production up and running. You have delays, and which then sort of amplify through the system. So the variation increases step by step, starting from the admission to down the flow. So in these kind of situations, you have a process that takes a special configuration. And we can call it mobilization. That applies to a situation that is typical in surgery, where you have a team of people that need to start the work together in a coordinated way. You also have a facility that needs to be prepared. So operating room must be cleaned, disinfected between every patient. You need to have a new set of instruments that have been through the washer so that they are clean and ready to go. Everything must be in place before you can start. So the resources that are there needs to be mobilized and be ready to go at one point of time. So this is not atypical in other industries, let's say in the airline industry. Before an aircraft can go, you have to have the cargo on board, the people on board, you have to have the fueling, everything must be done, only then you can go. Okay, so this is the mobilization of resources that you see. So different processes flow together at one point of time. In surgical hospitals, this typically is the problem. If the mobilization is not done properly, then everything is delayed, just simply because one resource is missing. So that in that sense, it's embarrassing and typically quite unnecessary, or it shows lack of discipline. Another aspect of this picture is that when you look at the preparations, so there is you have to do the backroom thing of staffing and scheduling, making the OR schedule. Now the team must be prepared, so you have to look at the patient data and decide what you are going to do. Then there is the patient preparation. So patient, sometimes you cannot eat for 12 hours before a procedure, you have to take some medication or something. And then the instruments and facilities need to be prepared. So this amount of work, according to a study that we did some years ago, is about 4 times the amount of work that is put in the actual sort of surgical intervention, which is interesting number. In another study that we did on general hospitals, tried to calculate the number of preparation and back office hours spent per 1 hour of direct patient contacts. Did I tell you the story? No. The number we came up with was 30. So 30 hours of preparations and back office hours per 1 hour of direct patient contact. So what does it tell you? Well, it's a complicated system. There's a lot of things going on behind the scenes, things that the patient never sees, that are still very important in getting the things rolling. The same, by the way, is true of airports. There's a huge amount of activities going on behind the scenes in the downstairs, where they have the cargo and catering and flight control and whatnot. There are maybe 5 or 10 times more people downstairs than the people you can see as passengers. So it's typical of many service systems. You don't see the back office. And the back office, it's important to remember, the back office typically operates like a factory. Why? Because there are no customers there. And as we have discussed earlier, and the definition of service is that customers get involved in production. But if customers are not getting involved in production, then the logic is not that of our services, it's a logic of manufacturing, or goods, the goods dominant logic, which to all us in industrial management makes life easier. Because manufacturing management in many ways is much more easier than service management, because you don't have all these variabilities and customers bringing confusion and all that. You can do the math and the numbers and optimize and minimize and maximize and do all these kind of things. So that's one way. Okay. Then depending on what you are doing, what is your problem, then different process description perspectives have been developed over the years. And if you look at some textbooks about process improvement or lean management, you can find more detailed descriptions about how this is done and what kind of data you and what kind of analysis needs to be done. One sort of typical perspective is the actor perspective. It's a picture in the upper left corner. This is also known as the swimming lane process model, because it looks like a swimming pool where you have these lanes and then the things move, each according to one swimming lane. So you follow the activity or what happens to one flow unit. So one patient, what comes first, then you might have decision points, you have data collection and documentation points and so on and so forth. So this gives a view of how the flow unit moves between different producers and in terms of time. Then you can use this bottleneck thing that we discussed yesterday. You can look at the capacity utilization level in each step. I think we come back to this later on this morning. I have a couple of videos on this that are pretty cute and I want to show you. Then you can look in the same way, look at resource consumption per step, or you can look at the value adding time in relation to non-value adding time. So this is pretty interesting to map when something happens and when something is not happen. Like I showed the other day, the patient in process thing. It can be shocking to see how little of the total throughput time is actually spent doing things. Then you can, particularly if you're in a factory, if you talk about logistics, then you can look at movements. This is sometimes also known as the spaghetti diagram, and it can be done automatically if you put some sort of GPS tracker on people. That has been done in many hospitals. You put the tracker on a nurse and then you track how many steps they walk during a day and put it on a map on the facility. And it looks like a plate of spaghetti or noodles. Because most of the time it shows that the physical movements of people and goods is not thought of at all. And I remember a study that was done on this, and they realized that in a typical inpatient ward, a nurse during an 8-hour shift walks something between 10 and 12 kilometers. Is that time well spent? Probably not. And then if you start to analyze the spaghetti, the noodles, how they walk, then you obviously find sort of spots that they visit very frequently and distances that they travel from one end of the world to another. And then you can start thinking what would be the smartest way to locate various kind of things, like say supplies, or where the computer terminal is, or where the nursing station is, to minimize the flow of people and physical goods. Then you can also, and this is interesting in services, you can combine physical and information flows. So it's possible to make a map only about where the patient data goes. So where is something added? Is it put into some kind of file? Is some sort of analysis doing, compounding, calculating, or whatever? So you don't follow the patient as an individual, you follow the patient as an information event. That then where information is added and it's watched and it's alterated and so on and so forth. So this, if you design software, then this is obviously the thing to start. Then of course you can also make decision maps. If there are a lot of decisions to be made, then you can look where are exactly the points where somebody makes decision. And then another way of doing this mapping is to take the core process, for example, follow what happens to the patient, and then map all the logistic flows or the support flows, and then draw a map where different supporting things connect to the main flow. This is directly from automobile assembly plants, where you typically have sort of main assembly line that then is connected with other sort of sub-assemblies that then have to meet. So it's like a river system essentially. You have the main river, and then you have all these side flows that come in, and you get some sort of tree structure of different flows. So again, there are many ways to look at what happens in the world. So you have to choose the classes depending on what is your problem and what you want to do. But again, these are abstract concepts like double-ended bookkeeping that do not, as themselves, do not have a physical reality. They're just ways to sort and select and group and emphasize and de-emphasize various kind of things in order to bring up some sort of observations and data that is needed to do whatever you want to do, improve productivity or quality or whatever. All right, and yeah, here we had the blueprint. The blueprint in technology has been published in many textbooks, so if you get this kind of task of improving a process somewhere in the real world, then check out the World Service blueprints. There are manuals that tell how to do this. In this picture, the interesting thing is the lines of what is known as the lines of internal interaction, line of visibility, and line of interaction. This is what I said about the airports. Service production systems, typically these lines that divide the front office from the back office, and then in the back office there can also be different sort of lines that separate various kind of flows. So they are emphasized in the blueprinting methodology. Okay, but then let's move to a different aspect of process management, and that's the question of how to organize production. So now imagine yourself in a situation that you are a hospital manager, or let's say a health service system manager, and you are starting up a new venture, and you have the capital. Some people have invested money here. You have acquired the necessary resources. So you have doctors, you have nurses, you have equipment, all these things, and then you have a building with rooms. So think of yourself. There's one morning. The organization is not there, but all the assets are there. So you are there in the morning, stand in front of an empty building, and in a yard in front you have 200 people have assembled there, eager and ready to start working. You have the doctors, the skills, they have the equipment, they have the machines, they have everything, but they line up in the yard in a sort of random order, and behind you is an empty building, and you have yet no organization. Your task is to start organizing this so that it becomes a hospital that can receive patients and do some useful things and help people and collect revenue. You start from a clean sheet, then what do you do? How do you start to think about solve this problem? Yeah.
Identify the different process included, then allocate to.
Yeah. You have listened now to the process management perspective, so obviously you say that. If you would be a medical doctor straight out of from med school, you would not say that. What would you say?
Start working, get the patient.
Yeah, that would be my thing. Okay, let the patients come. Let's get to work. Yeah, I hold my stuff in that room, and you that. Oh, okay, no, then never mind. Let them come and let's work. And then 2 weeks later, we realize that you have created a complete chaos and nothing really works, right? Another thing that the med school grad would think of is, can we have the picture there? A functional organization. Because for professional people, the sort of functional organization principle comes naturally, because it's about domain knowledge and it's about the steps. So there on the front yard you would have, let's say, 5 people who are specialized as surgeons. So assume that all these 200 people, they don't know each other, they have time to mingle, so in no time the surgeons find each other and they band together in a group and they say, okay, I don't know you, but you went to med school and you know surgery. Yeah. You know surgery. Yeah. Okay, good, nice. We are similar kind of people. We know what each other of us are doing. We have a common interest. Let's make a group out of us. So that is the functional organization principle. So you organize similar kind of assets in one organizational unit. So you create a surgical department. The same used to be true in factory manufacturing. For example, if you have a machining shop where you process metal parts, then you have different machines there like lathes and